So, I can calculate other property changes. Delta U is equal to U2 minus U1, which is equal to M2 U2 minus M1A U1A plus M1B U1B. Okay, this is my second equation. I can get the value of U2 is equal to UF plus X UFG or delta U, and again putting the respective values together, we get U1A is equal to UF at 15 bar and U1B is equal to U at 15 bar and 250 degree centigrade. Alright, putting these values, I can get 15 bar and 250 degree centigrade, from which I can get U1B. So, I can write as U1B is equal to 2695.9 kilojoule per kg. Alright, I can do further calculations, get the values from table. I know UF is equal to 842.83 kilojoule per kg and UG is equal to 2593.4 kilojoule per kg. This is what values I will get from table 2. So, from this table, if I put this back in this equation, I will get U2 is equal to 842.83, that is UF, plus 0.4273 UG minus UF. Putting these respective values over here, I get U2 is equal to 1590.85 kilojoule per kg. Alright, having got these values, now I can get delta U using this equation. Now I can put these respective values over here and I apply the same way as I did earlier. I can now compute delta U is equal to 33.96 kilojoules. Similarly, I do with the specific volume change also, and I get delta V is equal to minus 0.0228 meter cube. Alright, so there is a volume change that happens from V1 to V2. Alright, which is very important to understand, that there is a reduction in volume that happens because of this mixing process. Let us now understand the expansion work, W expansion work, which is P into delta V. Pressure is 15 into 10 to the power 5 Newton per meter square, into delta V is minus 0.0228 meter cube. From here what I get, W expansion is equal to minus sign 34200 joules, which is minus 342 kilojoules. So, this is the work done on the system because it has got a negative sign. So, W expansion is 34.2 kilojoules. What we can do also is to show the schematic of this on a PV diagram. If I want to show on a PV diagram now, alright, this is my state 1A, this is line of 15 bar, alright. So, this is 1A, which is maintained at saturated liquid and at 15 bar. So, this is point 1A. 1B we have found that it is a superheated region. So, somewhere around this point, 15 bar 250 degree centigrade, 15 bar saturated liquid, and we also found out that when these two streams came together, this stream came from here, this stream came from here, both of them came and this mixing resulted in a wet steam which has got X as 0.4273. So, somewhere around here was state 2. This is how we can show that because of mixing of 1A and 1B, point 2 came as a state 2 because of this process. So, if I see the piston arrangement, this was 1A and 1B, and as soon as the state 1A got mixed with state 1B, The state 2 resulted in decrease in volume, and because of which this piston came somewhere at this point, and which is why we got W expansion work as negative, which is work done on the system. Right. So, because of this saturated liquid and superheated steam got together, the piston actually came inside, which is what we say work done on the system. Answer to the entire question now is, we got delta V12 as a result of this mixing. We had reduction in volume minus 0.0228 meter cube. We had delta E12 approximated as delta U12, which is 33.96 kilojoule. W expansion work is negative minus 34.2 kilojoule, and we found that at point 2, which is a wet steam, we got a 0.4273. This is the dryness fraction of the wet steam at state 2, what we got as a result of this mixing phenomena. This is a very little bit involved problem, where we understood that two streams of different nature got together of 1A and 1B, because of which property changes occurred, and because of which some work got done on the system. I think these 4 problems actually will give a good idea about what kind of problems that need to be solved using water properties, water phase diagrams, and again integrating all that knowledge to basically understand the first law of thermodynamics applied to practical systems. Thank you very much.